All right, so today we're talking about system of equations. So, like the last class, we talked about inequalities and the system of inequality. And I said inequalities is just graphing one inequality and it's done. And then if there's more than one inequality, those are called system of inequalities. So this is called system of equations. That means this is more than one line, okay? So what happens if there's more than one line? Well, there are three possibilities if you draw two lines on random, okay? What would happen to those two lines, right? So there is several things that happen. One, the first thing that can happen is pretty simple. That two lines would just intersect at some point, right? So it will intersect at one point, and that would be the solution x comma y, okay? So notice that this doesn't have multiple number of solutions like a system of linear inequalities where this only has one solution. It's gonna meet at one point. Another situation that can happen is two lines are correct. I hear you yelling in the background. Their two lines are parallel. Same slope. Different y-intercepts. What is the third possibility? Do we know? I'm so confused. I don't know. All right, so there's my red. Where will my blue go? Well, it's literally the same exact line, meaning they're literally on top of each other. So that means it's not just the same slope, but also the same y-intercept, okay? Now, in this case, there's going to be multiple points where they intersect, right? Because they're on top of each other, so there's going to be multiple points of contact there, okay? So, in fact, every single point that red has, blue will have also. So that's why that is going to be the interesting one. All right, so let's go through the different methods of solving systems of equations, okay? There's two methods. One's called substitution, and one's called elimination, okay? So let me put a problem down here for you. Let's say I use this. Again, you got the squiggly bracket. So let's say it's 5x plus 2y is equal to 8. And the other equation is x minus 3y is equal to 5. Okay? So I'm going to show you both substitution and elimination. Okay? So let's do substitution first. All right, so here's the thing. With substitution, here's what you want to do. You want to look at these coefficients and say, which one of these does either equation have one coefficient that is a 1? Okay, and the answer is yes. And the answer is yes. It's this one right here. This has a coefficient of 1. So if that's the case with substitution, that is what I want to do. I want to solve for that x. So I want to take this equation and I want to solve for x and get x by itself. So what do I have? I got x is equal to 3y plus 5. Then I want to take that and substitute it into the first equation. Okay, so let's see here. This is equation 2. So now I want to call this equation 1. So I want to take equation 1 and put 2 into it. So 2 is going to go into 1. All right, so let me write this one out. 5x plus 2y equals 8. I solve for x here, so that means I want to replace this x right here with, with this x right here, okay? So that's what I want to do. All right, fine, that's what we'll do. So I have 5 times plus 2y equals 8, and that is going to be 3y plus 5, because x, that's what x equals to. X is equal to 3y plus 5. Okay, so now from here, now I'm down to one equation with one unknown. So now I just finish. So I get 15y plus 25, because I have to distribute that 5, plus 2y is equal to 8. Then I have a 17y is equal to, gotta subtract the 25. So I got what? Negative 17. So my y is equal to negative 1. Okay? So I want to hold on to this to like dear life. I want to keep this near me. Okay? All right. So now what you want to do is you got to figure out. So this is telling me that there is a point that is going to intersect and the y value is negative 1. So now I got to find the x value. What you should do is go back to the original, the x minus 3y equals to 5, and substitute that y in there. So I got x is equal to, x minus 3 times negative 1 is equal to 5. X minus, plus 3 is going to equal to 5. So x is equal to 2. So now I have an x and a y. What the heck is going on? Oh, that's why. Let me see. There we go. Okay. So now I have the point 2, comma, negative 1, and that would be my answer. That is my answer. Shoot, not what I wanted to do. And there we go. So if I was to graph these two lines, they would intersect at 2, negative 1. Okay, and that is my solution. Okay, so what about elimination? Okay, so what about elimination? So let's use orange. So that still looks really reddish. Let's use purple. Okay, so with elimination, what do I do? Okay, so let's take a look. So I have the first equation to be (5x plus 2y equals 8), and the second equation to be, let's use orange, x minus 3y is equal to 5. Okay, so with elimination, I just need to decide if I want to get rid of x's or y's. Okay, there's an advantage on both. Well, there's not really an advantage, but like if I look at this, if you look at the y's, if I want to get rid of y, I have a 2 and a negative 3. Okay, what I need is that the coefficients to be the same and opposite signs. So one positive, one negative, but the same number. Okay? Obviously 5 and 1 is not the same number. 2 and negative 3 are not the same number. So, but I could get the orange x to be a negative 5x, right? And that would give me 0 x's. I could get the negative 3 to be a negative 6 and a 2 to be a negative 6. And that would get rid of my y. So it's up to you what you want to do. You can multiply both equations by something, or you can multiply only one equation by something. It is really up to you. Okay? So here's what I would do. I would say, okay, since I see a positive here and a negative here, I'm going to go with eliminating the y. So what I'm going to do here is I'm going to multiply this by a 3 and this by a 2. And your question is, why? Well, because, again, I need this coefficient and this coefficient to be the same. One's positive, one's negative, right? So the only thing that would be common, like a common multiple, 6, 2 can go into, so can 3. So I want the coefficient to be 6 and 1 to be positive, 1 to be negative. So the top blue one would become a positive 6. The bottom orange one would give me a negative 6, which would, when I add, will eliminate everything out. Okay? So let's take a look. Let's see what happens. I get 15x plus 6y is equal to 24. And I have a 2x minus 6y is equal to 10. So I have that now. So what I need to do from here is to add. So if I was to add these two, what do I get? I get 17x is equal to 34. So x is going to equal to 2. Now I can either go back and do elimination again, but getting rid of x instead of getting rid of y's, right? So this way, right now, I just got rid of y and solve for x. I could get rid of x and solve for y. Or you can just put the 2 into one of the originals. So if I take the bottom one again, and it doesn't matter which one you put it in, it should go into both. So I have 2 minus 3y is equal to 5. Move the 2 over, I got negative 3y equals 3, so y is equal to negative 1. So again, I have that my two things is I get a 0.2, negative 1, which is still the same answer as this one here, okay? So I personally like elimination better, but it's really up to you guys of which way your brain works. So again, with substitution, you still want to look at the coefficients to see if there is one variable that has a coefficient of 1. Because if it does, then it's a lot easier, okay? If you were to graph these two lines, then I'm going to tell you that wherever they cross would be the answer, okay? Now, I'm going to do several more problems here, okay? So let's do something like this. Let's put another example here. Let's say I have 8x minus 3y equals 13. And negative 5x plus 2y equals negative 7. Okay? So here, I would never use substitution because if I was to look at the coefficients, none of them are 1. Okay? So if I decide to get y by itself on top, right? If I was to try to get the y by itself, I would have to divide everything by negative 3 at some point. Well, now I got fraction and fraction. Yikes. Doesn't sound like something that you guys want anyways. Call me crazy, but I don't think you guys do. All right, so let's take a look at anything. It's just not going to work out very nice. So in this case, I would use substitution. Okay, so if you look at, you got to decide you want to get rid of x or y's. Let's say I get rid of x's this time, right? The other one I got rid of y's. Okay, so let's say this time I get rid of x's. So what can 5 and 8 both go into? And the answer is 40. So what I'm going to do is I'm going to multiply the top one by 5 and the bottom one by 8. All right, it would give me a positive 40 and a negative 40, so it will go away. So the top is going to give me a 40x minus 15y is equal to 13 times 5 is 65. And the bottom one is going to give me a negative 40x plus 16y is going to give me a negative 56. All right. So when I add these together, what do I have? Y is equal to, is that a 9? Gives me a 9. Okay. So now I've got my y value equal to 9. So all I have to do is take one of the original ones and plug y into it. Which would you rather do? Let's take the top one. Why not? So I want to take this one here. I want to say 8x minus 3y equals 13. The y is 9, actually. Okay, so I have 8x minus 3 times a 9 is equal to 13. So I got 8x minus 27 is equal to 13. Add the 27 over, so 8x equals a bunny flying by. What do I have here? Ooh. 13 plus 27 is 40. So x is equal to 5. So with this being said, I have a point of 5, comma, 9. And there's my answer. Okay? So there we go. So question is, when are we going to see this? Right? So far, there has been a point that actually crosses. When are we going to see, and what is it going to look like when we get something like this? Okay, great question. I guess we'll have to do more examples. All right, so example. What did I say? We're going to go with that. Okay, so here we go. So let's say I have x minus 4y equals 8 and 2x minus 8y equals 8. Okay, so you want to do substitution or elimination? Well, since I did elimination here, let me choose substitution here because I see that this coefficient has a 1 as a coefficient. So I'm going to take this right here. I'm going to solve for x. So x is going to equal to 4y plus 8. And then I'm going to plug it into the bottom one, which is going to be 2 times 4y plus 8 minus 8y is equal to 8. Okay, so I got to distribute the 2, so I get 8y plus 16 minus 8y equals 8. Oh no, look at what happened. Look at what happened. What does that do? It goes away. So I'm left with 16 is equal to 8. So here's my question. Is 16 ever equal to 8? No. So this is a false statement, right? So if it's a false statement, that means that they actually never ever touch. So therefore, this is going to be a no solution. And there you go. Okay, let's do another one. All right, so again, if it gives me a false statement, then I know there's no solution. Okay, notice I didn't have to go and find anything else, so y just kind of goes away, so therefore I have to leave it. Okay, so let's try another example. I have 7x plus y is equal to 8. 2y is equal to 16 minus 14x. So here's my recommendation. I would recommend to put everything the same, okay? Now, you could do substitution here because if I divide, well, number one, the top says that y, I can get y by itself. But if you look at the bottom, if I divide by everything by 2, that will work as well, right? So either way would work here. You guys can decide, but I'm going to put everything looking the same. What do I mean by that? What I mean is this. So the top is 7x plus y equals 8. On the bottom, the 2y I can just leave there. The equal sign I want to leave there. The 16 I want to leave. But the negative 14x I can bring over and put it under the 7x. And to bring it over, I got to add 14x. Okay? And the plus is because the 2 has no symbol in front of it or sign in front of it, so therefore it is a positive. Now everything is lined. Now I can say, okay, what do I want to get rid of? Do I want to get rid of this and multiply by negative 2? We could do that. The top is going to be what? A negative 14x minus 2y equals negative 16. And what does the bottom look like? 14x plus 2y equals 16. Well, if I add these, what happens? 0 is going to equal to 0. Now, this is a true statement. That's a true statement, which means it's going to be all reals. Now, what does my last plus do? My last plus does this fancy thing. The solution set of the system is x comma y, therefore, such that 7x plus y is equal to 8. Okay? So in other words, given a point on this line, it's always equal. Okay? So this would be infinite number of solutions. Okay? So, again, if I was to label this, let's label this as A, B, and C. So, this would be an A. This would be an A, because we found a point. This one here is a B. And this one here would be a C. Okay? So those are the different choices. Now, I want to do one more example. I know you're getting tired of it, but this one more might save you. Okay? And here's why. Because when you see it, you'll be like, oh, should probably stay around for this. Let's have 3/5 x plus y is equal to 26 over 5. And I have negative 1/8 x minus 3/4 y is equal to negative 39 over 8. Okay? I got fractions. I got fractions everywhere. And you're probably going, I don't like fractions. Anxiety's starting to go. Anxiety's really starting to get high now. What do I do? What do I do? What do I do? Right? So here's the thing. I can get rid of those denominators and change those fractions to whole numbers because they're both equations. So the top, I could multiply the top, in other words, every single term by 5. Okay? So you got to think of it this way. So essentially what I'm doing is I'm multiplying the left side by 5, which I got to distribute, and the right side by 5. So in this case, I would get a 3x plus 5y is equal to 26. Okay? So if you look at this as over 1, the first one would be 15 over 5, which is 3, or you can think of it as the 5 cancels out, I'm left with 3. All right? The bottom one, what do I do to multiply every single term by to get rid of the 8 and the 4? Again, this is just like LCD. It is LCD. So if you multiply everything by the LCD, so which is 8, then I could get rid of the denominator. The first one is going to be a negative x minus a 6y is equal to negative 39. Okay? So you can, in the middle term there, you can reduce the 8 and the 4 to be a 2 and a 1. And then 2 times 3 is 6. And it's a negative in front, so that's why it's negative 6. Now you can continue on from there in terms of what you want to do, okay? So I could multiply the bottom by 3 and get rid of the x. I could solve for x and then plug it back in. Either way, doesn't really matter, okay? So let's do it both ways, okay? So if I was to do substitution, let's say, okay, substitution. So what I'm going to do is I'm going to take the blue equation, and I'm going to solve for x. So I got negative x minus 6y is equal to negative 39. So I got negative x is equal to 6y minus 39. So if negative x equals that, then positive x would equal to negative 6x plus 39. Okay? So, or think of it this way. I'm dividing everything by a negative 1, right? Because there's an imaginary 1 in front of that x. In this case, a negative 1 in front of that x. So I can divide everything by negative 1, or I can multiply everything by a negative 1, and it'll still give me the same thing. Okay? Or I can just think about flipping all the signs. That will work as well. All right? So let's talk about, let's keep on going here. Now we got to plug that. So this was the second equation. I now got to plug it into the first equation. The first equation was 3x plus 5y equal to 26. Okay, so I got 3. Now I got to plug in the negative 6x plus 39. So what do I get? I get negative 18x plus 39 times 3. 117 plus 5y equals 26. Whoa. Houston, we have a problem. Sorry, that should have been y. So therefore, this should have been a y. So therefore, this should also be a y. Sorry about that. So I got negative 18y plus 5y gives me a negative 13y. And that's going to equal to 26 minus 117. So negative 91. So y is going to equal to positive 7. Okay? So if I do that, now I got to just pick one. So whichever one I pick doesn't really matter. Let's pick the blue one back up. So the blue one is negative x minus 6 times a 7 is equal to negative 39. Negative x minus 42 equals negative 39. So negative x is equal to 3. So x is equal to negative 3. Okay, so my answer is negative 3, 7. Okay, so I want you guys to notice that when there's no solution or infinite number of solutions, those are really short. But when you have to do substitution or elimination, it gets really, 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 really long. Okay, so let's do this with substitution. Elimination, sorry. Okay, so I have 3x plus 5y equal to 26. Negative x minus 6y equals to negative 39. How about this? Let's just multiply this bottom one by a 3. Ooh. So I got the top is 3x plus 5y equals 26. The bottom I'm going to get a negative 3x minus 18y equal to a big number. 39 times 3 is going to be a negative 117. Then I divide. And what do I get left? The x's goes away. I have a negative 13y is equal to negative 91. So y is going to equal to 7. And if I plug it in, then my x is going to come out to be a negative 3. So my solution is going to be negative 3 comma 7. And there you go. Well, I hope this helped. It's a little bit longer of a lecture, but if you have any questions, let me know.